At-fabric caching is a distributed in-memory key-value cache that provides .NET developers with a way to increase performance and scalability when writing data-centric applications. Well, that's all fine and dandy, but what does it really mean? Well, as you can see up here, we have clients as we usually do with any application, and they're using at-fabric caching, but they have a unified cache view. So when they're using at-fabric caching, everything looks like one big chunk of cache, right? It's distributed in-memory cache, but on the back end, there's multiple servers acting as a cluster, talking to each other, and using the combined RAM of all these servers to put all the objects into cache. Now, you can put any .NET serializable object into cache. It doesn't really have to be in this string kind of things. You can add another server onto the back end without the client really getting affected, things of that nature. So why would you want to use it? Well, usually when we write applications, they're always data-centric, right? There's really very few apps without applications. So we would use stuff like relational data or service calls to get the information. So for example, if you had a store proc that brought in all the that brought in all your products for this week's specials, you want to it may tax your SQL server, might have some CPU spikes or whatever it might be, but you want to bring that data and you want to cache it because that's not really changing a whole lot. Or you might be using service-oriented architecture, might have to go out to a vendor or a partner, get their catalog in, and you don't want to really do that again and again and again as you're going through this, and you might want to cache that. So at-fabric is about increasing performance by bringing the data physically closer to the consumer. So what kind of data do we store? Well, there's reference data like product catalogs and stuff. There's activity data, such as shopping carts and other transient data, and resource data, such as inventory, orders, and other core transactional data that you might want to consider caching. And each one of them has pros and cons, whether you want to cache them and how you want to cache them. So the logical layout kind of looks like this. To a client application, everything looks like a unified thing. So a cache cluster, which may have 3 servers, and on those servers might have a process running, which is a distributed cache service. And you have a default cache by default. And that default cache, it comes out of the box. You might want to use it, you may not, or you may want to create your own name cache. So for example, here we have a name cache called product catalog. And then there's things called regions. The regions are actually represent a partition of data, a subset, which the cache uses to, or the at-fabric uses to partition how everything is allocated. Because for each one of these caches, they're not all sitting on one server. They're distributed across the server. And regions can be implicit or explicit, and you can use explicit regions. And I'm not going to get into regions and stuff. A lot of this is documented pretty well. But I want to get to a more interesting piece that I thought was more interesting and it wasn't well documented. So this is maybe what your favorite website.com might look like. You have servers that go to a cache cluster. There may be one or many servers in there. And in the back end, there's a configuration store. That may be a file share or a SQL server. And this is where it becomes a little interesting. Well, why do we have a file share or a SQL store? Is everything stored in cache? I thought it was in everything stored in the database. I thought it was in memory. What kinds of things are stored in here? Well, there are 2 kinds of things that are stored in a SQL or a file share. And it's called the cluster configuration. There's a configuration store and a cluster management. The configuration store actually stores what is in the cache, not the objects, but what the cache looks like. So, for example, we have name cache, we have product catalog, and we have default. When this cache server start up, they want to know, well, what do we look like? How should we look? So they go out to the database or a file share and say, well, we have 2 caches, name cache and default, and these are the regions. Or actually, it doesn't say regions. Cluster management. The other piece that happens is the cluster management piece, which is keeping the cache cluster running at all times, monitoring the availability of all cache flows. and helping cache hosts join the cache cluster. So how does this happen? There's basically two choices, either through SQL Server or through XML configuration. Well, if we talk about SQL Server, then you usually have a SQL Server cluster, which kind of manages where the store is going to be, and the store is usually in the database, and then the actual cluster management piece where it's talking about doing health feeds and stuff like that is done through the SQL Server. So you don't have to worry about lead host management or configuration, which we'll talk about a little later. And you don't need to worry about recovery mode because all the cache services can be started at the same time or in any order. And that will get into the more lead host configuration. And the cache cluster will continue to run even if only one cache server is still online or still active. So what that means is, so we have 3 servers, and let's say two of those 3 servers went down. Well, the cache will continue to run because we still have one server that's able to process those requests. And because all the management piece is done by the SQL Server. But the cache cluster is dependent on the SQL machine at all times. If it goes down, the cluster will go down. And it won't just shut down gracefully, it'll crash. There'll be an fabric crash, which is very irritating. So then SQL Server becomes the single point of failure for the entire cluster. And while our services crash, when SQL Server is down, no new node can be added, or cluster can be restarted because everything is dependent on the SQL Server. And the other important thing is during install, you need elevated permissions on the SQL Server. So that becomes very interesting if you work in an environment where everything is really locked down and you need a DBA to help you install something on production. XML configuration. The good point is you don't need SQL Server. You don't need the added expense of a license or anything else. But it requires lead hosts. So where SQL Server, you had the heartbeats going to the SQL Server, now the lead hosts talk to each other. So each server could potentially become a lead host and say, hey, are you alive in my life? Are you alive in my life? Kind of thing. And there's no single point of failure. The interesting thing here is the cache is able to run even if the file share where you had the configuration goes down. So if the cache is running, your storage goes down, that cache is available, it's running, and it's more resilient than SQL Server because if the SQL Server goes down, you're dead in the water. It's difficult to manage because you need to worry about lead hosts and ensure each host is configured properly. If we lose a majority of the lead hosts, the cluster will shut down. And then the recovery mode, when you start the cache cluster up, you need to have the lead host start first. So we talked about if configuration is no longer available, the cluster cannot be restarted, which is understandable because whenever the cluster starts, it asks for what's my configuration. There is no support for NAS or SAN unless it's DFS, and that's not natively supported in the install. You need to do workarounds, and if you need to manually run start cache host after reboot. So my findings were the documentation is severely lacking, it's incomplete, and I've talked to multiple people about that. SQL configuration is recommended on MSDN, but now they're talking about moving it to XML configuration. But on the customer advisory, whatever the CAT team is advising XML, what MSDN is saying that's SQL Server. NAS and SAN is not supported. It's not going to be supported in the next version. Performance standards are not so helpful. Administration is through PowerShell, which makes it look like a child. There's a trial and error pattern. You have to try everything and figure out whether it works for your environment or not. There's really no good guidance on doing things. And there's a capacity planning tool that really works.